Explain like I'm 5 what are 32 and 64 bits in computers and what difference do they make? Does it make the computer faster? And how are they different from 8 and 16-bit video game consoles? This value is called the native word size, and it determines the maximum number size the processor can operate on in a single step. A 32-bit computer can work with 64-bit or even larger numbers. But it has to split operations into multiple steps. For example, to add two 64-bit numbers it would need to take twice as many steps. In practical terms, this makes it slower when working with large numbers than a 64-bit computer. This is an oversimplification, but it's the gist of things. 32 or 64 are the bandwidth of a computer's instructions. The CPU of a computer takes in 32 or 64 bits and does some kind of instructions on that. Bigger calculations that don't fit in this have to be split into multiple instructions and have to store some temp result. You want to tell me how to do something? If you can say 32 words in a breath versus 64 words in a breath, you can see how the 64-word scenario would have the ability to tell me the instructions in fewer breaths. 32-bit versus 64-bit represents the size of each block of information that can be processed. There's a bit more to it, but this is the explain like I'm 5 version. Well, 8-bit gives you 2, 8, 256 unique values. If you use these as byte addresses, you can only address 256 bytes. 216 gives you 65,536 bytes, which was a massive upgrade. 32-bit allows you to address 4 gigabytes. So this is effectively your maximum RAM size. 64-bit allows us to smash through that limit. Think of 64 and 32-bit as packages handled by a post office. A 64-bit package can contain far more information than a 32-bit package. It's like the difference between a postcard and a book. The computer is the post office and spends an equal amount of time sending and receiving 32 and 64-bit packages. But because 64-bit contains far more info than 32-bit, it has to move far fewer packages. Imagine sending the novel War and Peace by postcard instead of one book. Essentially, a bit represents either a 1 or a 0. The more bits a computer has, the bigger the values it can use. For example, the biggest number a 8-bit computer can get to is 2, 8, 256. Each bit has two states, either 1 or 0. And we have 8 of them, which means the largest number it can get to is 255, 0 to 255. 256 numbers. You can't calculate anything that has a result larger than 255. Same thing with 32 and 64 bits. 232 4,294,967,296. 2, 64, 1.844674441E19. This is the main difference. A 64-bit computer can handle massive numbers at once. LMK if Y need to know more. Let's say you want a savings account at the bank. There are two options. The 32-bit option lets you have 4 digits for your balance. The most money you can have is $99.99. If you deposit $100, the extra penny is lost. The 64-bit option lets you have 8 digits for your balance. The most money you can have is $999,999.99. If you deposit $1 million, the extra penny is lost. 64 bits lets you store more accurate numbers than 32 bits. There's way more to it than that. But that's the explain like I'm 5 explanation. Imagine how big numbers can get with 5 digits. All the way to 99,999. Now imagine how big numbers get with 10 digits. 9,999,999,999. The second number is so much bigger it's actually 99,999 times bigger than 99,999. A computer needs to put a number on each thing. With 32 bits, 32-digit numbers. Computers can put numbers on about 2 million things. With 64 bits, computers can put numbers on 4 million things. When computers can put numbers on lots of things, they can do lots of stuff. This makes them faster since they don't have to stop doing one thing to start doing another thing. Take it as highway lanes. If you had one highway with 32 lanes and another with 64 lanes, which would move traffic faster? A mega superhighway in East LA has been upgraded from 8 lanes of traffic to 16, and then to 32, and then to 64 lanes wide. That's a lot of cars moving. Now a data bus in a computer is upgraded similarly. 8 conductors to 16 to 32, etc. That's a lot more data moving. It's how much information can be processed at once. Imagine it like words on a page. Books for toddlers have 1 or 2 words per page. 6-year-olds have a paragraph per page. And 10-year-olds have pages full of words. More words per page means you can process more information faster. Imagine you want to send a mail to your friend. But you can only write 32 characters in a mail at a time. So in order to send a sentence of 50 characters, you have to send 2 mails, which requires more time and work. Now, however, someone invents a new kind of mail where you can send 64 characters per mail. So now your 50-character mail can fit into a single mail, and thus you have reduced the time and work to send the information to your friend. So basically it is about bandwidth. i.e., you can process more data in 64-bit per operation. Think of the bits as fingers on your hand. You can only count to 10 because you have 10 fingers. This limits your ability to do math. Magically, you now have 20 fingers instead of 10. You can do much more math now. To computers, everything is math. The more math they can do, the better they get. The 32 or 64-bit is the size of the register. Registers are these buckets that hold values when calculating large numbers via operations. If the register is larger, complicated operations like multiplication or division, subtraction, and addition take far fewer processor operations to execute. That's it. So, certain applications, at least core functionality processing, will work close to 2x faster on 64-bit. On the same clock speed. It's like lanes on a highway. More lanes, more cars, traffic moves faster. 32 bits is like a highway with 32 lanes. 64-bit is like a highway with 64 lanes. In general, more is better.